I'm Fatin. I will talk about objective. So the first objective is applying SLAC, stateless, and IPv6 stateful in order to overcome the limitation of IPv4 addresses. So it means we will find a solution to overcome the problem of IPv4 addresses. The second is using DHCPv6 to auto-assign the IPv6 addresses to all the end devices in the other country. So using the hash CPv6, we will avoid to manually configure to all the end devices. The third is proving the differentiation between IPv4 and IPv6 addresses in both logical and physical topology. The last one objective is assisting Trancedata choose the most convenient network configuration to apply on the company's network. Next is problem statement. So we have 4 problems. The first one is the lack of address space. The description is the number of different devices connected to the internet grow exponentially and the size of the address space is quickly. Due to the world becoming more advanced, the IPv4 addresses usage has reached a limit. The second is weak protocol extensibility. The insufficient size of the IPv4 header, which does not accommodate the required number of additional parameters. The third one is the problem of security communication. No means are provided to limit access to information hosts on the network. IPv4 has never been designed for security. So, IPv4 didn't have security to secure the end device. The last one is geographic limitation. Since the internet was created, the usage of IP addresses will be increased. Almost 50% of all addresses are reserved for high technology countries such as UK.
My name is FARAH AFIQAH and I will explain about the scope of the project. Okay, so this is our project scope statement and our project name is upgrading Trancedata network into IPv6. The description of this project is the limitation of IPv4 addressing have been bothering all the users to access the resources they want. IPv6 addressing will be needed to overcome this problem. And the deadline of this project will be at 26 June 2023. And the manager of this project is FARAH WAHIDAH binti Azlan. And our goal to achieve in this project is to ensure that despite the expanding number of devices and services, all end devices in various countries receive the IP addresses using IPv6 implementation. And the deliverable of this project is the IP addresses assigned reach to all the users in various countries. And one of the in-scope items of this project is improving the limitation IPv4 address to IPv6 address, and then enabling the allocation of addresses for all devices, network and services. And lastly, implementing security to protect against threats like unauthorized access. Our scope items for this project is implementing Ether-channel in the both topology, logical and physical topology, and configuration. And then isolating the traffic for each group by using VLAN configuration. And lastly, enable centralized IP address management and simplifies the process of figuring network settings for devices. The constraints for this project is this project must be done before 19 June, 1 week before the deadline.
Assalamualaikum, my name is FARAHIN binti Fizan and I work as the IT manager at Trancedata company. So here's the physical topology of the IPv4 before the implementation of the IPv6. So as you can see here, there is a router at the Malay headquarters, which is the HQ of Trancedata. The router is connected to the router in the Australia and UK branch. So there's a centralized server at the Malaysia branch, and the router is connected to 4 switches, a switch for each department, and the switches are connected to 20 end devices. Okay, here is the logical topology of the IPv4, before the implementation of IPv6. So you can see here there's 3 routers. Each router is for each branches, and a router is connected to one. Each router is connected to one switch, and the switch is connected to it uses IPv4 addresses. As you can see, in Malaysia we use 192.168.2. In UK we use 192.168.3, and in Australia we use 192.168.1 network. It all uses 24/24 subnet. So this is the physical topology of the IPv6 implementation. So as you can see, there is a connection from router to router, UK router to Malaysia router, Malaysia router to Australia router back to UK router, to create a loop for the network. And also there's the use of wireless access point to enhance the scalability of the network of Trancedata. And also we have we use all IPv6 addresses to overcome the depletion of IPv4. So this is the logical topology for IPv6 like. So for the router-to-router connection, we use 2001 db8 ACAD ABC network, and then for Malaysia we use 2001 db8 ACAD 10 network. For Australia we use 2001 db8 ACAD 3 network. For UK we use 2001 db8 ACAD 20 network. So in this topology, in this slide, in implemented topology, we use the addresses with /64 subnet. So here's the logical topology for the stateful IPv6 on Trancedata network. So as you can see, it's pretty similar with the stateless Slack topology, except that for this one we uses the /52 subnet, and the address for each branch is quite different. The prefix is the same, but it's 2001 db8 ACAD 3000 network for Australia, 2001 db8 ACAD 1000 for Malaysia, and 2001 db8 ACAD D2000 for UK.
Now I will be explaining to you about how we assign IP addresses for each network. So we move on to the stateless network. For our first 48 bits, we just put the standard 2001 db8 ACAD. That is for the first 48 bits. We have used that for every network in our, every local area network in our network at Trancedata. That is the first 48 bits, and this is where it changed. For Malaysia, we have used the 1/64, put the 48 bits, and then 1, and then there's the 64 bits for clients use, for the users to use, and that's why we use the 64 as our subnets. And then for the UK, you put the 48 basic standard 48 bits that I explained earlier, and then we put 2, and then /64. For Australia, we have used 3, and then for the router Malaysia to connect with router UK, we have used the C. So it would be like 2001 db8 ACAD C, and then there's the range and 64.
And then for the router Malaysia and router Australia to connect, we have used the network B. And for the router UK and Australia to connect, we have used the network A. So it's 2001 DB8 ACAD, the first 48 bits, and then A, and then the range 64 bits range, and then 64 subnet. So we have used the standard subnet 64. So the range 64 bits will be vary by the client's use as they assign IP to the clients. So moving on to the stateful IP addresses, we have used this time it's a bit different because we've used the 52 as our subnet. So the first 48 bits we have used the same 2001 DB8 ACAD, but we have changed the 16 bits in the middle because we have changed our subnet into 52. So the 60 bits in the middle start with 1 and then 000, and then there's the 64 bits of IP range because so as we all know, CPv6 is more preferable for the larger networks because it can maintain fine-grained IP allocates and configurations and network parameters. So it is more preferable for larger network. So we think that, as we all know, that the lower the subnet is, the higher the IP range are. So if the stateful DHCPv6 are used for larger networks, then they will need more IP address. So we lower it down to this 52 subnet. So the range could be a lot more because you will get 80 bits of range. Can change up to 80 bits because the 64 subnets is only 64 bits, the range that you can vary. So for the Malaysia, we use the 1000. You put the 48 bits, that is the 2001 DB8 ACAD, and then 100 subnet 52. So then there's the 64 bits. And then for the UK, we have used the 2000 and then the 64. And then for Australia, the 48 first subnet, first 48 bits. And then we use the 300 for Australia, and then the 64 range. And then for the router Malaysia to UK, we have used the C000, and then for the UK to Australia, we have used the A000, and for Malaysia to Australia, we have used the B000. So back to the IPv6 network address, it will be the first 48 2001 DB8 ACAD, and then there's a number that you can change, and then the 000. It's actually vary because it is the range that you can change. Depends on the client, how they want to assign to the clients. Moving on, we'll be talking about the implementation of the methods that we use in our network that we have suggested to Trancedata, which is the stateful and stateless. For the stateless, we have used the DHCP pool in our router Malaysia because we have made the Malaysia as our HQ, the headquarters. So we have configured the router Malaysia as stateless, and we have used the HCP pool as implementation in our network. So as you can see, this is the configuration for the DHCP pool on router Malaysia, and this is how we set up the stateless. And moving on, we have the router Australia stateless configuration where we put the into the interface, and we have the router Malaysia. You can see there stated there it's stateless. And in router Malaysia interface 301, we have put the configuration there for the Malaysia to get IP from router Malaysia, and also for this is the configuration. And this is for Australia, it is also stateless. And then we'll be seeing the stateful configuration. This is from every router Malaysia, router UK, and router Australia. So now we'll be moving on, and we will see the results of the implementation. So now we will be going into the results of stateless network. So as you can see, here is stated Australia stateless and UK stateless, and if you can see at the IPv6 address, you can see clearly that the IP that was received was 201 at 2001 DB8 ACAD3 for Australia and ACAD2 for UK. That was based on the IP address table that we have assigned, and it is successfully received by the clients, by the users. So that means our stateless implementation is successful, and this is the for PC. And for the results of stateful, you can see at the UK router, and this is from the users in UK and for users in Australia. It received the 2001 DB8 ACAD 2000 as the IPv6 IP address. So that means the stateful IP that we have assigned was successfully received by the users in UK and Australia, also by the Malaysia. As you can see here, it's stated as the 48 bits first and then the 1000. That means it was successfully received by the IP that we have assigned based on the addressing table that I explained earlier. So that's it for implementation and results of our network.
Okay, so for the discussion and conclusion, we got at the end of this project is SLAC, which is stateless address auto configuration, is simple and efficient, while DHCPv6, which is dynamic host configuration protocol version 6, will provide more control and flexibility over address assignments and network configuration. And then SLAC allow hosts to automatically configure their addresses without relying on central server, while DHCPv6 allows for centralized management of IP addresses and offers the ability to assign specific addresses to hosts. And then next, SLAC preferred in small to medium-sized networks where the dynamic nature of address assignment is not a significant concern. And DHCPv6 used in a larger networks or environments that require fine-grained control over IP addresses, allocation and configuration parameters. And lastly, SLAC will obtain their IP addresses through router, while DHCPv6 needs a server to maintain state by keeping track of assigned IP addresses. So the conclusion at the end of the project is DHCPv6 is the best choice to be implemented in order to overcome the limitation of IPv4.